How's it going, ViteConf? It's great to be here with you virtually, wherever you happen to be, whenever you're watching this presentation. But very stoked to talk a little bit about Vite here today. My name is Kevin. I'm a member of the Deno team. And today I'm going to talk a little bit about how you would use Vite to process static assets in combination with a server-side application that's mostly written using Deno. So for those of you who have never heard of Deno before, it's a JavaScript runtime that natively supports TypeScript, JSX, lots of the common developer tools that you would otherwise need to configure yourself, and generally is a JavaScript runtime that's optimized for performance and developer experience. And much of the NPM ecosystem is also supported on Deno today, even though Deno is not a drop-in replacement for Node. A lot of the common modules that you would want to use do work just fine on Deno today. So what we'll be doing is I'm going to start with just a quick demo that shows how NPM modules work in the context of Deno, and then we'll go to a slightly more complicated application where we'll show how you use Vite and Vite plugins to generate static assets to go along with your server-rendered Deno application. So let's pop over to my text editor here, and we'll write a simple a Deno program just to give you a sense of how Deno works. So much like the browser, the environment that you'll be programming in Deno has access to lots of global objects like you would have in the browser. So the fetch API, request and response objects, the built-ins that you would expect to have in the browser actually work on the server in the environment of Deno as well. And when there aren't web standard APIs that exist for certain features or functionality in the web platform, those are usually made available as a part of the Deno namespace. So kind of the canonical hello world application of Deno is deno.serve, and we can create a very simple web server that just returns a response. So we'll say return new response, hello world. And here we have sort of the very basic Deno web server, which I love. I certainly love to write every single time. And we can execute that in terminal with Deno run -a and then --watch, so we can see any changes to that file over time. And when we fire that up, we have a server running on port 8000 that will happily display for us hello world. So there it is. Whoops. Yeah, it looks like it responds to everything, even if I spuriously include an S in the URL. So a Deno program, very similar to a Node.js program in that regard. But one thing you'll notice is that a lot of the interfaces in Deno tend to favor web standards. So Deno serve, in this API, what you're doing is actually returning a response object, like the kind of response object you would get from the fetch API in the browser. So we try to favor those standards whenever we can. However, in addition to the built-in APIs that come with Deno, you can also use many of the modules in the Node ecosystem to build your Deno programs as well. So let's switch this up a little bit and then just create about the same thing in an Express application, Express being, of course, one of the most popular Node modules out there. So we'll import Express from npm express @4. So let's talk a little bit about like what this line of code is doing. So we number one, in Deno, we support ECMAScript modules by default, so there isn't a common JS module option. So all of the imports that you'll use are ESM imports. And within Deno, we also have this npm specifier. So that is indicating that we want to load a dependency from npm. And then we can also pin directly in the import statement, like what version of the dependency we want to import. So in this case, I just want the latest version of Express at version 4. So we have those, have Express loaded up. So we can create an app, say Express, set up a get route for the home page, and then there we need a request and a response object. Let's say res.send hello again. And finally, we will say app.listen on port 3000. So great. So we have now our Express app that's doing about the same thing. We have some red squigglies here because by default, Deno is TypeScript aware, and for Visual Studio Code, you can also install a plugin that will do linting and code completion. And it's complaining a little bit because it doesn't know what type these parameters are, because they're a part of Express rather than a standard object that we can infer type information from. So to add types here, what we can do is we can say at Deno types, and then pass in a string here, which will be the types package for the Express module. And I'm actually just going to grab that here because we want to keep things moving as best we can. So there we've added the types for Express, and now you can see that Visual Studio Code is satisfied, and it knows what those objects are. But we are getting some linter errors here because the request object isn't used. So we'll just add that underscore, which is an indicator that we know that object isn't being used at this time. So we have our server ready, and if we go back out to the browser and go to localhost 3000 this time, we can see, hello again is coming up for us. All right, so that's kind of just the very, very basics of how Deno works. Again, ESM modules by default, support for the NPM ecosystem using those NPM specifiers, and then TypeScript by default are some of the things that we just observed there. So now we kind of have a basic sense of what's happening in Deno. Let's show a slightly more advanced example that uses Vite to generate some static assets. So I'm going to switch over to another project. And this project, I'll show you the GitHub repository for it in just a little while. But basically, it is set up to use Vite within the context of a Deno project to do a couple of tasks for us. So what I want to do is, I have a server application here that uses a framework called Hano, which is a very lightweight framework that's kind of runtime agnostic, very similar to Express in many respects. And I have actually set up a route that will render JSX in response to some of those routes. But what isn't supported by Deno by default is compiling front-end assets. So like if I needed to compile TypeScript to a JavaScript file that can run in the browser, I have to do a little bit of extra work to do that. And similarly, if I want to use CSS files, especially dynamically generate CSS files that could support something like Tailwind classes, which is already configured on this H1, there is a little bit of extra work that I need to do. But before I do that, let me just make a couple quick changes here to comment these things out. Whoops, that's because that's JSX. I need to do that in a slightly different way. So let's do that. Cool. All right, so we'll comment that out, and then we'll do the same for our script tag down here, just so we can kind of see the before and after for each of these states. So with this configuration, what's going to happen when I run this server? If I do Deno task dev, it's going to start the server on port 8000. But if I head out to Arc and go to this page, what I'll see is an H1 that hasn't been styled. So this doesn't have Tailwind CSS styles associated with it, even though I have these utility classes that are attached to it in the class attribute here. So I need to set up my project to actually provide this information to the client. So within my source folder, I have another client folder here, which will contain the assets that I want to be compiled and included in my final project. So my index.ts here doesn't have very much code in it, but it could have TypeScript because Vite will happily compile TypeScript for us. But it also uses some Vite-specific features like the ability to import CSS files within the context of your front-end JavaScript. And then within that index.css file, right now I just have kind of the Tailwind components that I know I'm going to need in order to add those utility classes to my HTML. So I have a couple of front-end assets here, none of which are in their current form able to be used in the browser. So that's kind of where Vite comes in. So in the root of my project, I've created a Vite config file, which uses define config to set things up like build options and plugins. Like if I was using Svelte or Vue or other front-end frameworks, I could configure those plugins here. Right now, though, I'm just going to kind of configure the build to take that index.ts file as sort of the entry point to the build, and then output JavaScript files and assets kind of by the same name. So for simplicity's sake, I'm not going to deal with kind of the manifest. So a lot of times when you use Vite in a mode with a backend framework like a Rails or some other like server generated HTML frameworks, you generate a manifest file and then you actually dynamically include URLs there. So we're not going to do that just for this demo, but that is something that you would probably do in sort of a production scenario like this one. So we configure our build here, and the other thing that we're going to need to do is configure Tailwind so that when Vite tries to parse that CSS file or process the CSS file, it'll have the ability to do that. So the way in which you set that up in a Tailwind project is you add a Tailwind config file and a post CSS config file. Neither of these are terribly exciting yet, but the Tailwind config file is configured to look in my source folder, and we'll look for Tailwind utility classes that are used in any JavaScript, TypeScript, or JSX, TSX files, and it'll examine those files, understand which utility classes are being used, and then output some CSS based on that. So in order for that to work, the Tailwind post CSS and like a couple other dependencies are required to be installed in the node modules folder in this project. But of course, we're using Deno, so Deno by default doesn't have a node modules folder. Most Deno programs will actually dynamically include dependencies using the npm specifier, as in the syntax that I showed a few minutes ago, or you'll actually include those dependencies within a deno.json. So that has kind of an embedded import map file, which again is kind of based on the web standard import map, where you can have a mixture of both NPM dependencies and other dependencies that you can use in a Deno project. So for example, Deno is capable of importing HTTPS URLs, kind of like doing a import in the browser where you actually specify a full path to a file that exists on the network somewhere. You can configure those types of dependencies in a Deno project too. But these other dependencies from NPM, these just need to be there in the node modules folder the way that Vite and a lot of the Vite plugins expect them to be, or else it's not going to Vite is not going to work the way that I want it to work. So because Deno doesn't have that node modules folder by default, I actually created a build task that is going to run Deno with some specific options, such that it will generate a node modules folder that has all of those dependencies in it. So this npm install task, which again I won't step through the entire thing, but basically what it does is it dynamically imports all of the dependencies from my deno.json file that start with an npm specifier, and generates a node modules folder by asking Deno to like download and cache those modules in the same way that it would if you were using the npm specifiers in your code directly. So there is a little bit of special sauce there, which again you can check out on GitHub if you want to see how it works. But it provides this Deno task npm install, which generates that node modules folder for us. And then the dev task, which we've already seen, starts the app server. So, and then the app server right now is sort of hard-coded to serve static assets from the dist folder, which is generated from our build step. So I'm going to actually just kill that real quick so I can show that second step. So I'm going to say Deno task build. And that actually uses Vite to generate some assets for us. So an index.js and an index.css. So if we look in the dist folder, we have the index, which didn't have too much code to transpile, so it's just our hello world. But our CSS file actually has quite a bit there. There's all of the CSS that Tailwind requires in order to have those utility classes work. And then we also have a public folder here, which just has the Vite SVG. So all of the assets in the public folder, as they do for all Vite projects, kind of get copied in by default. So now that we've generated those assets, we can go back to our server code and uncomment those lines and actually include the JavaScript files and CSS files that should enable us to actually use those Tailwind classes here. So we're going to uncomment that. And there we go. Save that, and then if we go back out to localhost 8000, we now have our Tailwindified version of that H1 using the Tailwind utility classes. So once again, we went through the code pretty quickly, but if you'd like to check it out, you can just head out to my GitHub repository. It's just github.com/kwhinnery, and then I have a Deno Hano Vite template project, which will contain all the code that I just showed you. So that's all the time I had for today. Definitely was a quick one, but I had a lot of fun showing you a little bit about how Vite works in the context of Deno, and I hope you check it out real soon.